All right, these notes are going to cover ships and planes, and we're going to introduce the concept of navigational bearings and headings. So I just want to refresh your memory. A rotation angle is what we've been working with. They start with 0 degrees on your positive x-axis, and they rotate around in a counterclockwise direction. We have 90 degrees straight up, 180 degrees left, 270 straight down, and one revolution is 360. And that's what we've been working with on our unit circle. Now, when we talk about bearings or headings, if you are going to fly a plane or navigate a boat, you are going to follow directions using bearings or headings, and that is using this guy. Oops, I made that an S. Meant to put an E. Where 0 degrees is straight up, 90 degrees is to the right. They rotate in a clockwise direction, so I have 180 degrees directly south, 270 is west, and then one full revolution, 360 is back up top. So in the real world, you will use headings and bearings. For what we're learning, we are using rotation angles. Rotation angles are only to be used on the chart, so I want to just make myself a note, rotation only. If you are given headings or bearings, you must convert them to rotation angles to get the correct answer. Okay, so example 1, it says, from port, a ship travels due east for 18 miles, then turns and heads southeast for 12 miles. So here is the vector going due east for 18 miles, and then here is the vector going southeast for 12 miles. And they're not labeled, so I'm going to call this guy vector U and this guy vector V. And then the resultant vector, this is U plus V. Okay, and then over here on my chart, this is U plus V. Just so I know which vectors I'm looking at. So the first question says, write down the navigational bearings for traveling east and southeast. So if we're looking at navigational bearings heading east, east is directly 90. So 90 is the bearing for east. Southeast is going to be exactly halfway between south and east. So if 90 degrees is directly east, I need the value that is exactly between 90 and 180. And just like our rotation angles, exactly between 90 and 180 is 135. So southeast will give me a bearing of 135 degrees. Okay, so part B says describe these headings with a vector sum. So our first vector is 18 miles, that is my magnitude, and going directly east. Now remember, this is rotation angles only. So if we're going directly east, rotation angle would correspond to 0 degrees. And so that's 0 degrees. That is there is no vertical motion, only horizontal motion in the positive direction. And so that vector has components of 18, 0. All right, our second vector, from the tip, we're going to be traveling southeast. Okay, so southeast on a rotation, I'll do that in another color so we can see that. That would be exactly right here, bisecting fourth quadrant. And so we can either identify this guy as -45, or if we wanted to do a positive rotation, how about 315? And either of these angles will give you the same answer. I'm just going to use -45. And this one's traveling for 12 miles, so the magnitude is 12, and that's -45. All right, so to find the components of this one, I am going to have to do a little bit of math. The x component is equal to the magnitude times cosine of the angle, and you'll get the same answer if you use 315. And the y component is the magnitude times sine of the angle. And let's visit Desmos so that we can find our components. Okay, so I already have them in here. That's nice. Make sure you're in degrees because we are using 45 degrees. And so we can see 12 cosine of negative 45 is about 8.5. And 12 sine of negative 45 is about negative 8.5. So 8.5, negative 8.5. Now let's just look at that little vector there, vector v. To the right and down, 8.5 to the right, 8.5 down, so that matches. Now I want to find the resultant, and so to do that, we use this chart the same way we've done before. We're going to add these down and then work it left. So 18 and 8.5 is 26.5, negative 8.5. Those are the components of the resultant vector. And if we look at it, it's moving to the right 26 and down 8.5. And so that makes sense. Our a value is positive, so we don't have to worry about adding 180. Inverse tangent of the b value divided by the a value. And our magnitude, again, is just the Pythagorean theorem, 26.5 squared and negative 8.5 squared. And so let's go back and do some math over here. Okay, so I need inverse tangent. And this is negative 8.5 divided by 26.5. And it's okay that the negative went off to the side. That's fine. The whole quantity is negative. And then the square root of 26.5 squared. This does matter, though. You need to have the negative in the parenthesis. Otherwise, you will get the wrong answer. You've got to be squaring the negative. So the length of this magnitude is about 27.8, and the direction is about negative 17.8. So let's see, the direction is negative 17.8 degrees, and the length is 27.8. Okay, so at the point, describe how far was the ship from port, 27.8 miles. Okay, example 2. From port, a ship travels on a bearing of 40. And so, again, I'm going to go ahead and label this. This is going to be vector u. This is the first vector. And on a bearing of 40 for 30 miles. So I know the magnitude is 30. And I'm going to have to do a little bit of math. A bearing of 45 is going to give me a rotation angle. Now think about if this is 0 degrees rotation, each quadrant measures 90 degrees. If the bearing is 40, what value is going to be complementary? What is going to be the complementary angle? And that's going to be 50. 40 and 50 make the 90 degrees. All right, so to find the x components, x is equal to magnitude times cosine of the angle, and the y components magnitude times sine of the angle, and we'll visit Desmos to find those answers. And then the second vector, we'll call this vector v. U and v are just so common with these vectors, so I'm just going to keep up with that. And that one is on a bearing of 140 for 55 miles, so I know my magnitude's 55. And let's just think about this. If my bearing is 140 and that's from the north, I need to figure out the rotation angle. So this is 90 degrees. So 140 minus 90 is 50 degrees. So this angle, this amount is 50 degrees. In a rotation angle, I can either say, well, he's a negative 50 degrees rotation angle because they start with 0 degrees here. Or if I wanted, I could use a positive rotation, go all the way around, and I'm going to stop, and that would be at 310. So 50, negative 50, or 310 would correspond to that bearing of 140. And I'm just going to use negative 50. Either way, you'll get the same answer. And so the x component is going to be magnitude times cosine of the angle. And the y component is magnitude times sine of the angle. Okay, so let's go visit Desmos and get those values. So let's see. I'm just going to clean these all up. 30, cosine, 50, 30, sine. And just to make sure, I'm just going to double check, make sure it didn't change. Yeah, I'm still in degrees. And that should have been 30. Okay. And then I'm going to have, what, 55 cosine. This time my angle is negative 50. And 55 times sine of negative 50. All right, so those are all the components. So my first vector has components of 19.3, 22.9. I guess I could just round to 23. So 19.3 and 23. And my second vector has components of 35.4 and negative 42.1. Okay, so let's add those. So let's see if we can do that. That's 0.7, 9, and 5 is 14. Carry the 1, 3, 4, 5, 54.7, and then 42.1. Can't do the subtraction as easily in my head, so let's see, that's 1, 9, 10, 11, 12, and how about 19.1? Okay, so those are the components of my resultant vector. And we did the rotation angles. I just put them in the chart, so they're there. Same thing that we've been doing before. So inverse tangent of the B over the A, and magnitude is just Pythagorean theorem. And let's go back to Desmos. Okay, so let's see. Inverse tangent. And I'm going to have to look at my numbers again. 19.1. Oh, I knew there was something weird. It's supposed to be a negative. If you think about the resultant vector, we're going to the right and down. So I knew this value right here should have been a negative. So I'm sorry, but we figured that out. Put on my negative. Negative 19.1, 54.7. Okay, so negative 19.2 would be my direction. And then there is my magnitude. So about negative 19.2, 57.9. Okay, so question C says, at the point, describe how far is the ship point 4 from port 57.9 miles. That is the magnitude, that is the length of the vector, the resultant vector. And it says, if another ship leaves port to meet the original ship, what bearing should be used? Okay, so this one's a little different. I'm going to draw a picture for this one. Negative 19.2 degrees is just an angle a little bit below the x-axis. Remember, this is a rotation angle, so this is my negative 19.2 degrees. It's a little bit below the x-axis as a rotation angle. So if I wanted to convert that to a bearing, that's what it's asking me. So if I put 0 degrees up here as a bearing, this is north, what bearing would this be? Well, if each quadrant represents 90 degrees, this quadrant is 90 degrees. Remember, directly east, this is west and east, east is exactly 90 degrees. So if I wanted to give a bearing for this rotation angle, it would be the sum of 90 and 19.2. It would be this obtuse angle, 90 plus 19.2. It is a positive 19.2 because we are working from the north and we are going further than directly east. And so what is that? 90 and 19.2, 109.2.